Okay, don't freak out. This is an LG, and there's lots of strange things going on with this one. Sam will step us through the booby traps.
Yeah, this one was a bit of a journey. I had to go on a vision quest for this one to
Yes,
figure out what was going on
Vision
here.
Quest. Very
Um,
good.
and by that I mean I had to go and get vision on the parts label on this one as part of figuring that out. Um, so the issue that our tech encountered was um, he was getting water to the ice maker, but not to the water dispenser. So we've got our valves up here. We've got three electrically. We've got three valves here.
And Sam, let me just interject. The colored lines that you're seeing, Sam didn't do those. This is
Correct.
from the LG tech sheet.
Yeah, those are to represent the wire colors, the actual wire colors. Um, so electrically, we've got three valves here. We've got the pilot valve, a valve for the ice maker, and a valve for the water dispenser. That's what those are. And so there are a couple of things as the tech was trying to figure out how to even go about troubleshooting these valves. There are a couple of things that threw him for a loop. Um, the first thing was, what even is the spec on these different valves? Um, right, so right here, it's saying that the pilot valve is a 120 VAC valve. Um, however, if you look elsewhere in the documentation, here is the valve from the point of view of the this sub board. This is the dispenser board here, and so we've got the pilot valve there. One side going to the board, the other side going through to the neutral connector there. And here they're saying, so it's 10, pin 10 right here. They're saying that that's a 12-volt valve. That's weird. Why would they say that there and have it explicitly called out as 120 there? So when you've got a conflict in the specs on the tech sheet slash service manual like that, and you're just trying to figure out, okay, what is the actual spec on this part? Um, is this a normal 120 VAC valve? Is this a small like 12 volt DC valve? How do you figure that out? Where would you normally look?
I would look on the part, the label on the part.
Exactly. You gotta leave the land of the tech sheets and go out into the wild web and go look up some pictures of the parts labels. And so that's exactly what I did to try to get some clarity on that. Um, it was a little harder than it could have been because the valves were not clearly labeled. And there was also two valves, right? Because we were looking at a total of three valve coils here, a pilot valve, an ice maker valve, and a water valve. However, as hard as I looked, I could only find two part numbers for valves. And that was this one and this one. But by looking at these, I was then able to figure out, oh, okay, we've got a dual valve here for this one. So that would explain. So we've got, while electrically there are three valves, there's actually only two part numbers that we're dealing with because one of these is two valves in one, and that's this one. And so now we have to figure out which one is which because that was not clearly labeled in documentation either. And that you can kind of figure out intuitively. Um, so if one of these is just a single valve and the other is a dual valve, one is the pilot slash the isolation valve, the other one has to be the water and the ice valves. So this dual valve is the water valve and the ice valve packaged into one. So and you guys are all familiar with how these water systems work. You've got the isolation valve that lets water into the unit, and then you'll have a secondary valve that directs the water to the correct place. And in
Yep.
this case, that's either the ice maker or the dispenser. So now that we've identified which one is which, we have to get eyes on these parts labels down here, which a lot of pictures were like this, where it's too blurry to even read what the spec was on those. But I was able to find a different one. So for this one, for the dual one, says right there. It's 120 valve. That's the spec on that. Great. For this one, I was a little more confused at first because if I look at this sticker right here saying 5 volts DC, does that mean that this is a 5-volt DC valve?
No.
No. And why not?
What's the little gadget that it's attached to?
Exactly. This is we got actually two different components here packaged together. You got the valve up here, that's this part, but down here, this is actually a little DC flow sensor.
Yep.
And you can find that on the schematic down here. That's what that looks like. A little 5-volt DC flow sensor. So you have to look elsewhere, and I had to dig up the part label, and I eventually found it. That's the part number for this one. And the valves are, of course, also 120. So we're not dealing with any weirdness of there being, you know, low voltage DC valves here. All three of these coils are 120 valves.
Now we're dealing with erroneous specs again.
Correct. And so then the question becomes, why are they saying here that you have 12 volts on this valve? Is it that when the valve receives power from the dispenser board, it can be powered by a lower voltage? Is that even possible? And let me show a clearer schematic. This is that same thing, just drawn with different schematics. So this diagram and this diagram showing the same thing, but different schematic drawn slightly differently. And the thing I wanted to point out is, so you've got your pilot valve or your isolation valve, whatever you want to call it, there on pin 10. But you've also got that same pilot valve connected over to the main board on this third pin of the main board. And so you've got this tag off here that's going off to that sub PCB, to that dispenser board. What would be the purpose of that? Why are there two different connectors to the line supply for this valve? In other words, why can the valve receive line from two different places? It can receive it from the main
Well,
board.
one will have to be for the ice and one will have to be from the water.
Correct. Exactly. So it can get line from either the main board or the dispenser board because it depends on what is being called for. The dispenser board doesn't have anything to do with the ice maker. So it has no way of knowing that the isolation valve needs to be powered because the ice maker needs to get water. That's all handled by this main board. So the main board is able to power the pilot valve when it's trying to get water to the ice maker. But when the dispenser board wants to dispense water, because the customer is pushing the button to do that, it also needs to be able to send voltage to that isolation valve and also then to the water valve right here. It has to power both of them at the same time, of course, for water to actually come out there. It's all making sense? Everyone following?
Mm-hmm.
Yeah, again, this is just that process of figuring out how does this circuit work. And and sometimes you got to do some jumping around and piecing things together from different parts of the manual.
Yep.
To get
Especially
the
when you
answer.
got bad specs like this. I mean, that's, I had to go on that whole journey of looking up the parts labels and stuff just because of this block here. And the answer turned out to be what you'd expect it to be. They're all just 120 valves, but you had bad specs, so you had to confirm that they were in fact bad specs. And if, by the way, the I found out why they have those stupid specs there. It's because they copy and pasted. So here's from elsewhere in that same doc, where it's talking about the circuit of this duct motor. That's the dispenser duct that lets the ice out. You'll notice identical spec that they're giving here. So in fact, they just copy pasted this spec block, dropped it over onto
Oh, good
this
find,
page,
Sam. That's good. I see what you're saying. Yeah, yeah,
and
yeah.
then just changed the labels over here and called it good.
Yeah, yeah, yeah,
They're like,
yeah.
oh yeah, surely, the valve still uses the same voltage as that little puny
The
duct
little
motor.
stepper motor in
Gotcha.
the ice flap.
All right.
So
I
it's just
see
the
where the
draftsman.
mistake was.
Yep, they just copy pasted this table.
It's
You
just
actually
sloppy
see it.
documentation.
Yep. And you see it multiple places throughout that manual where they've just taken the same table. They've not changed these columns. They've just copy pasted them around and then changed the labels over here. So this is yet another reason why we hate dummy directions, because this is from the dummy directions section of the manual. Sometimes you have to look there for specs, but you always have to kind of be suspect of what they're showing you and if it's correct. So that basically gets us to where we need to be on this to understand what's going on in the circuit. We've got a pilot valve that can be powered by either the main board or the dispenser board. You got the ice valve that's powered by the main board. Got the water valve that's powered by the dispenser board. They're all just 120 valves. In our case, where it's not dispensing water, what would you suspect? What would be your load of interest?
The dual valve, the water valve.
Exactly, the water portion of that dual valve, the coil that's for the water side. Because the ice maker is working fine. The ice maker is getting water. And that means we know that the isolation valve, the pilot valve, is capable of working when it's getting voltage. And we know that the ice valve is working, of course. So we would be dealing with a couple of possible situations that we could figure out pretty easily with some testing. Either we've just got a bad water valve, that coil just could be burnt out, or we've got a situation where there's a bad power supply from this dispenser board here.
Right.
You know, either it's not supplying voltage to the water valve to turn that on, or maybe it's not supplying voltage to the isolation valve when it's supposed to, the
Right.
pilot valve. If either one of those is missing, then you're not going to get water out of the dispenser.
Yeah, you could have a broken wire on that, yeah.
Yeah, could be as simple as a broken wire
Right.
going through that door.
But to even get there, you had to figure out how this circuit works. Once you figure that out, then you know where you can make your voltage measurements. Because you're thinking, oh, it could be maybe maybe the dispenser board, if that's your hypothesis, is not powering either the water valve or the water pilot valve, the isolation valve. Well, now you got a hypothesis that you can test with an electrical measurement. So your next step extends directly from that hypothesis, which is measure voltage at the pin 10 and pin 11.
Yep. So you could just have the customer push a cup into the water dispenser, and then you could, put a probe there and over onto a neutral here. Okay, do I have 120 there? If you do or don't, then you try also over here. Alternatively, you could try, if you want to, you could try cheating those valves. You'd have to cheat both of them at the same time, which is a little tricky, but you could cheat both the water valve and the pilot valve. And then if you got water coming out, both the valves are good, they're both capable of running, and that you have a power supply issue.
And you can always put your meter on the load itself and see if we're getting power on it.
Yep. Yeah, absolutely. It's all about what's easiest to access.
Right.
And in cases like this as well, there's always the possibility of a broken wire, especially if it's the wires that are going through that door. Since we're talking about a dispenser here. So yeah, there's some value in just going directly to the load in cases like that.
Yeah, especially if you are getting your voltages at pins 10 and 11, you're getting your proper voltages and you're still not getting water out the dispenser, then yeah, you got to go back to the valve, make sure that voltage from the board is actually reaching the intended loads, plural, both at the isolation valve and the water valve. And if not, then yeah, you've just proven you have a broken wire in the door somewhere or in the hinge.
Good stuff, Sam.
Good. Yeah,
I
any
have
questions
a
on that?
question. If you're we're finished. If you had more to say, I'll ask at the end.
No, we're open to questions now,
Okay.
so go ahead.
On our pilot valve up there, we have that capacitor under it. That's mainly for water hammer, correct? So it doesn't when the powers or when you don't have 120, it just doesn't slam close. That capacitor allows it to close slowly. Is that correct?
Yeah, that capacitor will discharge back into that coil when power is moved. Yeah.
So it'll close slower opposed to just dropping out.
Like under the spring, just slamming shut under the spring.
Right.
Yeah.
Right. Okay.
Yeah, you'll have, instead of the electromagnetic field all of a sudden disappearing, the electromagnetic field will diminish slow, like half a second or a few
Yeah.
milliseconds, whatever it is, but just to stretch it out a little bit. And
Okay.
yeah, good question.
Oh, and one thing that'll clarify, you guys probably already know this, you guys are all sharp, but for the sake of the recording,
Not
I just-
all of us.
oh no, don't sell yourself short.
Speak for yourself.
For the sake of the
Honest.
recording, I wanted to point out the way LG does this, where they had these little circles. All that means is that when you get to one of those circles, and in fact they even label it in some places, but you just jump to the place where that circle is shown elsewhere, right? So you get to N1, that means that this wire is connected over to N1 over here. Those are electrically equivalent points. And same with something like B here. So if you see B there, you go down, oh, and you find there's a B down here. So those wires are connected. So that's all those different letter and number codes mean, is it's just, they didn't want there to be a big tangle of all these interconnecting wires. So they're saying, if you hit B here, just jump down to the next place you see B.
Of course,
And
Whirlpool would do that on
that's
their
it.
side-by-sides.
yeah, oh, rather than those big rat's nests that
Yeah,
they
those
have.
are the worst.
Gosh,
Yeah.
that is horrible.
It's interesting too, Sam. They're showing you that for B, they're explicitly showing you that it's all those wires go through the left door hinge connector.
Yes. So
Which,
these
I mean,
are
anytime you see splices or connectors, these are all weak points that are subject to corroding, disconnecting, whatever.
especially when they go through a hinge. Yeah. So
Yeah.
these are all some very suspect wires.
It's the first thing you look for on a Whirlpool, no ice, no water.
Yeah, I mean, considering that, I could definitely see there being there could be, a break in the neutral side of this water valve, and that's what's causing the issue. Unfortunately, we don't know exactly what's going on. The tech still has to go back out to try to resolve this one, but I'm hoping that he'll be able to watch this recording and that will clear up his troubleshooting and help him figure out exactly what's going on here.
All right.
Yeah.
Excellent.
That's all I got. So if you guys have anything else, we're all good.